Okay, so we we talked about 401 mix, dense graded HMA, SMA, stuff like that, and just going to go over some basics on how that's actually accepted at INDOT. We call that the whole thing is called quality assurance, making sure we're getting what we're paying for, and then at the end discuss some of the newer updates going on in the HMA world. I will say this is the first time I've given this presentation. The presentation I inherited was grossly outdated, so I just started over, threw a couple different presentations together, so we'll see how it goes. All right, so a big part of the quality assurance program is things we've already talked about, the certified plant program, the quality control plan that's required on the job, sets forth a lot of the, that's where it starts, a lot of the, how we ensure a good product. We do have the performance graded binder supplier program. That is also, it's essentially a qualified product list, or qualified product, we don't call them approved list anymore, but it's an approved list of where you can buy your binder from, a whole lot of stuff that goes on with that, QC data and all that. We have the CAP program, Certified Aggregate Producer Program. Ensure that the aggregates in our mixer, so that's the two components of asphalt right there. So for those who may not know, on the job site, the pay item is kind of tells you what's going on. That's where what we're starting with. So a lot of times this is what the pay item looks like. It describes ESEL category, the binder grade, where it's being placed, and then the mix size. So here's an example. This is ESEL category 2, which I got a next slide will explain what that is. PG grade, this is an intermediate and 19 millimeter. So here's what your ESEL grades are. That's equivalent single axle loads. It's basically how many trucks you got on the roadway. 3 and 4 are your higher traveled roadways. 2 are your 3-digit county roads, things like that. And then this bottom graph here, we don't really deal with the 4.75 millimeter mixes anymore, but I think there's a handful out there over the last couple of years. But bottom line is you're looking at either 30 gyration or 50 gyration mixes. That's part of the mix design. Probably a little outside the scope of this class, but it all starts with the design mix formula at the plant. And why do we do that? Well, this slide actually came from the original presentation, and back in the day, INDOT used to actually be at the plant. We'd be telling you what to put in the mix and controlling all that. We got away from that a while back, and so what we're doing now is we say, hey, you guys at the plant know what you're doing, and then we just let you guys work with the materials and equipment to provide what we want. So I'm not going to read through all that, but so it all starts with your design mix formulas. Again, there's different requirements depending on what part of the spec book you're in based on the pay item, but we do require it to come from an approved mix design laboratory. That's another list we maintain. Again, it has to come from a certified plant, and what is fairly new is DMF entry, for those who don't know. We used to, I didn't have a picture of it. We used to have Excel books that got filled out, and then those were emailed in, we'd email them back. Then you'd have to email us to assign that DMF to a contract item, and there's all this back and forth, and sometimes could delay stuff on the project. But so 2019, I think, is when DMF entry came out. the interface here, this is what it looks like. Similar to the Excel workbook. You can see the aggregate stuff on top, binder sources, all that. Some of the volumetric stuff, the gradation there at the bottom left. But so FYI, that's how they're submitted now. For those who've never seen that before. And what's nice about it is it keeps it all online, one place for everybody to look at it. And then the biggest advantage, I think, is you guys, or the producers, you guys can add it to the contract item without having to go through us. The system recognizes what DMFs are appropriate for what pay items, and there you go. So there's no delay there. Sometimes there'd be a weekend, like you want to pave on Sunday morning, and the guy's not in the office, and you don't know whether this mix is approved to pave or not. So it got rid of some of those issues. All right, we've seen this slide last presentation again. 401's where most of it comes out of. Your QCQA, HMA, 410 is your SMA. A lot of you probably know this, maybe you don't, but we define for dense graded HMA, we define lots and sublots. So a basin intermediate lot is 5,000 tons. So that is made up of 5 sublots, 1,000 tons each. Surface is 3,000 tons, with each sublot being 5 sublots being 600 tons. 3,000 tons. I heard a while back. I wasn't here when these were set up, but apparently that's 3,000 tons of surface is about equivalent to the same distance as 5,000 tons of base or intermediate. So apparently that's where those came from. I don't know. I could be just making that up. But 410 SMA is a little different on the lots and sublots. If you look, the sublot sizes are the same for intermediate and surface, but there's only 4 sublots in each lot, so it's a little different tonnage. And we'll get into that stuff later, but now you know. So we know what type of mixes we have. Now we get to the testing part of how we ensure, how we're doing this quality assurance. So we kind of looked at it a little bit before about plate samples. So INDOT takes, there is a training qualification for the contractor to actually get the samples from the roadway. INDOT witnesses that and takes that back to the respective hub or whatever to get it back to our labs. Those spots are selected randomly. We used to go through a whole exercise showing how those random numbers are determined. There's an ITM that you can kind of, I think it literally says to put your finger on there and close your eyes and whatever. But we also have programs now that can randomly select numbers and kind of just pop out a number where to take the plate sample. So hopefully we're getting more automated on that stuff. And like I said, we take the sample back to the lab. Kind of seen similar pictures earlier, but plate samples and cores from each sublot. We take 2 cores in each sublot randomly located. Same graph, looks a little different. Talking again about the plate sample layout. Not going to spend too much time on that. I did want to point out, we originally, this was in the original presentation because a few years ago, maybe going 5 years ago now, I can't remember. This chart used to have a whole lot of different numbers on it, depending on your mixture designation, what the minimum sample size was, and a few years ago we simplified it, and essentially as long as your plate sample has 11,000 grams in it, you're probably going to do it right. You can do a little bit less when it comes to OG, but for open graded, but as long as you target 11,000 grams, 25 pounds, you ought to be all right. Did want to point out that the cores are supposed to be 6 inches, and it actually in the spec says 6 plus or minus 0.25 inches. And we do, you know, it says not to damage the core. We've seen some come in that are damaged, and you know, our guys, they try not to make engineering judgments, so you know, they're running the core they get, and sometimes it doesn't bode well for density if that thing's been damaged when it comes in. Relating to that, the spec says that it actually says the contractor and engineer shall mark the core layer to be tested. So it puts responsibility on both contractor and INDOT personnel. And I get called back every once in a while. They say, hey, what are we testing here? And sometimes you can't even see where the layer difference is. You sit there and try to roll it. You can't tell. Or you can see the different layers, but you don't know whether you're supposed to be testing the intermediate or the surface or what. So all I'm saying is it's in your best interest to make sure that core is marked clearly when it goes for testing. And then fill the core hole with HMA within one work day. And I think I did want to throw this up there. This is fairly new. We put some areas where plate sampling and cores are exempted, and the bottom line was there was places on a job where a paver could be used, and you know, it's always better to use a paver when you can instead of a widener or whatever. But there's areas where a paver could have been used, but the contractor didn't want to because the way the spec was set up, if you use a paver, you're going to have pay plates there. So, so we added some of these exemptions. That way, you can go ahead and use that paver if you can. You know, providing a nice consistent mat, but you won't risk having a pay plate coming out of there. A big one is 25 feet next to a transverse construction joint. Mixture placed on an approach or a gore area. So I think that was probably during COVID when that got added. And then there's this is a picture from the plate sample area, and then where the core exemptions are listed, it also says within 25 feet of a pay plate, I think. So basically the core can't fall directly on where the pay plate was. So FYI. This is a very recent addition regarding core holes. We heard it in the industry meeting that sometimes when you go back and get an appeal core or something, you might not always have HMA on hand to put back in that hole. And we really didn't want cold mix going back in there. So I called around a couple other states, and apparently a lot of the surrounding states already do this, but we made an allowance to put a bagged concrete material back in that core hole. If that's your option. We have an approved list. Sorry, we call it a qualified product list now, of a bridge patch material that is allowed to be used in that core hole if you choose. So be aware of that. Plate sample boxes are required to be labeled with all this information. This is right out of the ITM, and this helps it along the way. Make sure nothing gets mislabeled, mistested, things like that. Usually something like this is printed on the box on the where you can handwrite in the blanks, or sometimes the sticker's printed off, whatever. And I will say it is I think it might even say it on the. Yeah, it says there. It says on the box ends for plate samples. I think that wasn't always in there, but you know, when we're stacking these things, it's a lot better to have that label on the side than on the top. So that's why we put that in there. All right, so it's after lunch, the food's hitting, and we're about to do some math. So just bear with me. So the different mixes are accepted in different ways, the way the pay is calculated. So we talked about sublots. When it's a smaller quantity, it's just accepted by single sublot. The test results from that sublot. When you're 401 mix by lot, when you get into a certain amount of tonnage, we throw in some statistics that we call percent within limits. SMA is just based on adjustment points, how close you were to the DMF gradation and binder content. Open graded, a little more simple, but it's still single sublot. And then we've talked about 402 certification. So what we're going to do is just quickly walk through each one of these. It's got a little bit of math in it, but we're just going to, it's more just to expose you to it if you haven't seen it before. At least, or when you see the, kind of see how the pay is calculated if you haven't seen that side of things. So to start off, this is out of the spec book. This is how the pay is calculated for single sublots. All right, let's look at, so it's paid on air voids, VBE, which is basically binder, and density. And this is all the confusing spec language that's in there, and I always like reading like the VBE. So your deviation from spec minimum, if it's greater than or equal to 2.0 and less than 2.5, then it's 1.05 minus 0.01 for each 0.1 above. Yeah, I'm already lost. Anyway, so I like tables. They're more simple anyway. So like air voids, this is a simple one. You just look up what the tested air voids were. So there's your target, 5%. That's a 1.05 pay factor for air voids. VBE, again, here's a table. It does reference deviation from spec minimum. So for example, you had a 9.5 millimeter. So per spec, the minimum VBE is 11. So let's say we tested a 13. So that's a +2. So there's your pay factor there. And then density, again, all that confusing language converted into a quick lookup table. Let's say you got 93% density. Look at that. You're at a 1.0% pay factor. So what do you do with all those? You throw them into an equation. And again, don't get lost with all the math. Just generally, just so you understand where it's coming from. We call it a sublot composite pay factor, and all it is it's combining what you got for air voids, for VBE, and for density. So those three factors. And so these are the numbers we just looked up on the table. So you just throw those into the equation, and it spits out. So this is a good sublot. You're getting 103% on that sublot. Okay, but that's just a number. How do you convert that into dollars? That's when it gets. You gotta go one more step. And so there's another equation. So you throw that sublot composite pay factor in there. L is simply your sublot quantity. So it's just tonnage times how much is in the bid documents, how much it cost. And then you have this sublot composite pay factor. And then on the very end there is that thing we kind of referenced earlier, the mixture adjustment factor. And I think we go over this. I think there's, at 3 we'll go over what, I think there's more specifics on what that is. But bottom line is some mixes are heavier than others. The aggregate weighs more. So since we pay on tonnage, you got to adjust for that one way or the other. One way or the other, either you guys are getting ripped off or INDOT's getting ripped off if the mix weighs more or less. So again, don't get lost in all this math. Just trust me that there's an equation on how all that's calculated. So let's pretend this one had a mixture adjustment factor of 1.012. So like I said, you just throw in tonnage, unit price, the sublot composite pay factor we calculated, and it comes out to QA. So what this means is you're going to get paid. You're going to get paid what was on the bid document. So you get 600 tons, but you're getting $1,316 more because it was a bonus. And just for fun, just for example, I threw this in here. If you didn't use that mixture adjustment factor, INDOT would have been paying $16 too much for this. So that case is a bonus. So if you notice, if it's just a 1% pay factor, it calculates to 0. So you just get paid 100% on the bid item. All right, so that's single sublot. So what do you do if you're paving a big job and you have multiple sublots? There's a way using statistics to kind of help ensure that we're getting what we paid for. So it throws in mean, it throws in the average and standard deviation of the test results between all the sublots. And this is an example. So you look at, let's say this is the actual core results from a job. You know, they both average 93%, which is pretty good. But which one's better? What would you rather have, 1 or 2? You'd rather have 2, right? Instead of it bouncing all over the place. So just paying on average doesn't help you out. So we throw in standard deviation, which is basically saying how much did all these values jump around among themselves. And here's a fancy graph. All it means is getting those results closer together, less spread apart, gives you a better percent within limits. And again, believe me, there's an ITM that has all these fancy equations for what percent within limits is, and then then it spits out these PWLs, these percent within limits, and then you plug those into an equation to get a pay factor. Those are the equations. Here's it in graph form. Again, don't get lost. I made a nice little table. All right, so I think in this example I picked, let's say it pops out a PWL of 72. So you go across it from 70, and you go down from 2, you're getting a 0.93 pay factor. So, all right, just a little bit more. Don't fall asleep on me. All right, so this looks just like what we looked at before. It's just combining what you got for air voids, VVE, and density. And so let's say we had test results. It popped out a PWL. We looked at that fancy table, and we figured out that air voids, we got a 0.93. Binder was great. We had a great VVE. And then, density was not so good, so we got a 0.82 pay factor on density. So you combine them, you get it's less than 1, so it's a 0.93, so it's less than 1, so you know it's actually going to be a, I think I might have said it earlier, I said it wrong. It's going to be a credit to the contract in this case, not a bonus to you, to the contractor. So in this case, 3,000 tons, getting paid at 93%, well, there's a quality adjustment there of $15,000. So not a good day, but that one's hypothetical, right? No big deal. So just like the EMF entry, we've made an online program for how we pay for HMA. You can see there it's got all the test information up top, and then some of that PWL stuff at the bottom. This also works for single sublot acceptance. So it's all out there. How many in the room actually deal with HMA Pay Wizard? Okay. All right. So a handful, or maybe 30%. So hopefully you guys like the program. I like it a lot better than all the Excel workbooks that were being emailed back and forth a million times. We've had some hiccups with it, but we're continuing to try to improve it. So, All right, so real quick, we're just going to run through SMA and open graded. Bottom line is just know that SMA is accepted by, it's not accepted by volumetrics per se, it's not, or you know, volumetrics. We don't make pills, things like that. What we do is we pay for it based on, was the gradation what we wanted, was the binder content correct, and how was density in the field. And again, here's more math. Just be aware. The equation kind of looks the same. You're just throwing in tonnage, unit price, and then adjustment points, which are, it's all on the spec, how they're determined. There's a worksheet for it. Just be aware. It's kind of the same thing. More math. Now, one thing I'll throw this in for free. SMA currently does not have a bonus system set up. So if you have any adjustment points, basically with SMA, you can get 100% pay, or you're getting a credit to the contract. So if you get any adjustment points, that's money that's going back to INDOT. And like I said, this is currently still in Excel form. This is what you receive from district testing. But there's more to come on that. OG, I just threw this in here. If you look, it's paid on binder and air voids. So we give you 45% pay for free. You throw in some binder and air voids, and there you go. Same looking thing. You get a sublot composite pay factor. And that's also handled by Excel workbook currently. OG's really, the use of it has been reduced a lot lately, but it's still used as a drainage layer. So you still see it out there. All right, 402 mix, that's the mix, low quantities, accepted by certification. You can see there, if you have less than 300 tons, it's accepted by 402. And then in 402, it says, 402, basically, we're accepting it on contractor results. And so we basically say the air voids have to be within 2% of the DMF, and binder has to be plus or minus 0.7. And it's very important that those certs match, or, are correct. It's happened a few times that we found out the information on the certification isn't what was actually tested, and it doesn't bode well. So that's an example of what the cert looks like if you haven't seen one before. All right, so that was a quick run through of how we accept asphalt based on test results. We take the asphalt back, the core is back, we test it, spits out a pay factor, and we convert that to quality adjustment. We also pay for pavement based on the smoothness. Brian talked about it briefly in his presentation. Why do we pay on smoothness? Well, it is a safety issue. The roadway is safer if it's more smooth. It does improve the ride quality, and believe it or not, it does improve pavement life. So that's why it's part of the pay factors. If it's not bumpy, the tires aren't going up and down, aren't hitting it, and not imparting as many loads to the pavement. So it does help with pavement life. There's 3 ways we currently accept it. It's either by straight edge, profilograph, or IRI. Smaller jobs might use a straight edge, 16 foot or 10 foot. And then your larger jobs might still be using a profilograph. We're like the last state that still has these. Dang it. They are being phased out. We are currently using the next slide. We're using inertial profilers. We're trying to switch to that. They're more safe, getting a person out of the roadway. But it's going to be a little bit before these are actually phased out. We're supposed to do full implementation of inertial profilers in 2023. But what that means is I think it'll start being inserted in contracts. So you're still going to have some stuff that was let earlier than that. I'm not sure if that. I think there's going to be a phase out period. But hopefully we'll get to inertial profilers very quickly, and you know, it's all computer based, lasers on the truck. You can drive with traffic. You don't have to walk the roadway, so hopefully that's a lot safer. All right, so I think I'm talking fast. So what's new in HMA? Excuse me. There's just a few things I want to talk about, some updates with our online programs, DMF Entry and PayWizard. I wanted to talk about VRAM, spray pavers, and real quick about intelligent compaction. So I showed you before a picture of DMF Entry. This is actually a screenshot of DMF Entry 2.0, which is hopefully getting released in late March, early April. I don't know the best way to say this. The original programmer didn't have a lot of forethought, and so they basically started from scratch and redid the program, put a lot more functionality behind the scenes. It'll probably work the same if you're already in there working with it, or people at your company are already using it. But hopefully it'll work a lot better. Here's a screenshot of what it looks like, the mix design looks like. There's your aggregates and stuff on top. So it looks the same as what you might be used to or would have seen, but just a little bit of a facelift, some more functionality in there. The big advantage with this new DMF Entry is it will accept SMA designs as well. So it'll now handle dense graded OG and SMA, and so that'll help clear up some things. And then with that, if we get DMF Entry up and running, hopefully we can get HMA PayWizard updated to actually accept SMA as well, and then eventually OG. So like I said, HMA PayWizard right now only handles dense graded HMA. So hopefully we'll get SMA in there starting construction 2023. We'll have everything in one place. Won't be so confusing. How many of you guys have seen the VRAM out on the job? Got some hands going up? Yeah. That's coming on pretty strong. For those who don't know, it's an attempt to replace the joint adhesive and joint seal requirements on the joint. So instead of doing all this stuff on the side of the joint and on top of the joint, this actually gets put down before you pave, and then you pave on top of this. And when that hot asphalt gets on top, it reactivates the VRAM, and it migrates up and seals it from the bottom up. So this also is nice because it's not really, it doesn't track. That picture on the left, the truck actually drove over it. I mean, it was less than a couple of minutes after it was laid. So you can place this way ahead of the paving train, come in later. It is more expensive, so that's why it has not just been fully implemented everywhere. Most everybody at INDOT likes it. They want to invest in it. It just, because of project scopes and budgets and blah, 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 we couldn't just release it everywhere. So it is coming on slowly. The current, or I guess former executive staff leadership they committed to implementing this in the 2026 spec book for Category 4 roadways. So our higher category roadways, interstate, 4-lane divided highways will have VRAM in the 2026 spec book. So it will just kind of build until then. I wanted to talk about spray pavers. Don't throw any tomatoes at me. So spray pavers, if you haven't seen them, they spray the tack coat as you're paving. This specific model here, there's spray nozzles at the front. So there's an emulsion tank On top there, the spray nozzles actually spray that where you see outlined in red there. And then there's some more nozzles on the back that actually spray where the wheel tracks are, so you're not tracking it. There's a close-up of how it sprays it, and one, this ensures there's no tracking, and then two, because we're not putting traffic on it, we can use the Cadillac version of emulsions and actually use polymer modified emulsions to really help with that bond. We are, as an agency, trying to use more of these. We are targeting our high profile jobs, more of our interstate, 4-lane divided highway type roads. So you'll see more and more of these. There's four contractors have bought one, so you may have seen this already. And then last slide, I wanted to quickly mention intelligent compaction. It's kind of currently been left as a QC option. I think off the top of my head, I think there's 2 contractors that actually have. First, let me take a step back. Intelligent compaction used to mean the fancy voodoo density meters on the roller that would tell you supposedly what density you were getting as you were going. I'm still not convinced those work, but especially since the supplier basically told me they were voodoo. But what really has advantage is that now there's equipment to map the temperature of the mat directly behind the paver, and to also, you can put GPS units on the rollers so you can map where the roller has been. And those 2 things are actually really nice and can improve your quality of the road. So there are a couple of contractors I know that have invested in the density roller mapping, the roller mapping, I should say, and who knows, maybe it'll catch on. I know currently at INDOT we're trying to figure out how to do more with less. Our paving program's expanding, but our personnel are not, so there's rumblings of maybe requiring intelligent compaction to help ensure some stuff out there. If we can't get inspectors out there, I don't know. We'll see where that goes, but that's really all I had on that, just to kind of introduce the topic. And then, all right, so my wife bought me these pants a few months ago. Actual pants I'm wearing, if you look, the color says asphalt. And I thought Brian might get a kick out of this, because I guess the asphalt now means gray, which, come on guys, we got to do better. All right, so anyway, I thought that was a good one. So yeah. Anyway, thank you.
All right, thanks, Nathan. I just want to say a couple things before you get started, if you don't mind. As Nathan mentioned, we are, as a department, looking at, as he put it, ways to do more with less, looking at maybe ways we can not have an inspector out on the job all the time, but what ways we can still have assurance that we're getting a quality product. So we're going to probably want to start talking about more of those things, like the path mapping, things like that. The other thing I wanted to mention real quick, and Nathan, I wasn't sure if you had it in your presentation, but for us it's been a few years now, but for some of you that maybe came to this course a while ago, the density target. So how many of you in the room have heard of SuperPave 5 or heard that term? Raise your hand. All right, how many in the room know that the density target for 401 mix is 95% now instead of 93? A show of hands. So that changed about 3 years ago now. So all the jobs that you've been working on the past couple of years should have that. What I've heard, and initially that may have been an issue at some companies getting the education out there. You know, we got the message out to the people that were testing the mix in the labs, that were designing the mix, but the folks in the field may not have realized initially that, hey, listen, we're instead of, 93% used to be really good. Now if you get 93%, you're going to get hit. If you average 93%, you're going to get hit with some penalties now. So I just wanted to mention that, and I wanted to curious how many in the room knew about that. We didn't have it in these slides, but it was an important change from about 3 years ago now. So